So they're asking us for the linear velocity, the angular velocity, and the ratio between the kinetic energies, and if any of these answers are dependent on the mass or the radius. So the radius equals 34.5 centimeters, and this is going to equal 0.345 meters. We have our mass of 1.80 kilograms, and we have our theta of 30 degrees, and the length of the incline being 10.0 meters. We have the moment of inertia of a sphere, and this is going to equal 2mr squared over 5. And we know that omega equals v over r. We're first going to have to find an equation for velocity. So we can say that energy, and this is due to the conservation of energy, energy initial equals energy final. In the beginning, there's only gravitational potential energy from the mass. And at the end, there is translational kinetic energy as well as rotational kinetic energy. And we know that this is going to be equal to mgh, mass times gravity times height. And here, height is going to be L sine of theta. So this will be mg L sine of theta. And this is going to equal 1 over 2 mv squared plus 1 over 2 I omega squared. We know that, we're simply going to substitute, so half mv squared plus 1 over 2, and then it'll be 2mr squared over 5, and then it'll be v over r squared. This r is going to cancel out with this r. This 2 will cancel out with this 2. And we find that mg L sine of theta is going to equal 1 over 2 mv squared plus 1 over 5 mv squared. And this is going to equal 7 mv squared over 10. So we know that v is going to be equal to 10 g L sine of theta over 7 to the 1/2. And if you're wondering where the masses went, well, this mass is going to cancel out with this mass. So after that, we can actually find v. So for part A, v is going to equal 10, 9.8, 10 sine of 30. And this is going to be divided, 30 degrees, and this is going to be divided by 7 to the 1/2 power. And this is going to be 8.367 meters per second. We know that omega equals v over r, so this will be 8.367 divided by r, which is 0.345. And we find that omega is going to equal 24.251 radians per second. So this will be one answer for part A, and this will be the other answer for part A. For part B, they're asking us to find the ratio of the kinetic energies. So kinetic energy translational divided by kinetic energy rotational, and this is going to equal half mv squared divided by 1 over 5 mv squared, and this will equal 5 over 2. C is going to equal v. So C asks us, are these dependent on mass? So v is 10 gl sine of theta divided by 7 to the half power. That isn't dependent on mass or radius. So v not dependent on m or r. And then it's asking us, how about this one? Well, this right here is also not dependent on mass or radius. However, omega, which is equal to v over r, it's not dependent on mass, but it is dependent on radius. And that's the end of the solution. Thank you for watching.